Here's a video to show an example of the programming capabilities by using the API in programs such as AutoCAD, Inventor, SolidWorks, and Revit. And what the API is an anagram for Application Programming Interface. And what it allows is programming languages like VBA, VBNet, Python, JavaScript, and C++ to be used to write programs that automate drafting processes and also allow data to be exported and manipulated so that you can, in my instance, I've taken 3D models and I've used the API, and I use VBA typically because it works very well with Excel. VBA is the programming language that's used for Excel macros. And so I'll make a 3D model and then I'll export data out of that 3D model that allows for some very quick determination of costing and material utilization. So it's really powerful, and it also speeds up the design process and also allows for changes to be made very rapidly. So basically I build a single 3D model, and then from that 3D model, estimating, procurement, and even the fabrication department is affected. I can speed up processes out on the floor depending what's being fabricated. In this example, what I'm doing, this right here, this is an AutoCAD 2002. But this right here is a framing subassembly of a roof for a 24 by 30 foot garage. And so it's got 4 hips, which are these green entities on the 4 corners. This is a ridge, and then all the red entities are rafters. And so this subassembly is the roof for this project right here, which is a garage. So you're looking, the view on this, I'm looking at the right front. So here's the right wall with 2 windows in it. And here's the front wall. It's got an overhead door with a man door right here. And then this is the roof right here that was put on top. So each of the walls is its own subassembly. There's joist framing that's a subassembly. I've got sheathing on this project that I'm not showing right now. Those layers are shut off. But it just provides an entirety for the project to check fit, material lengths, and then from this I can just export the data, and it'll allow me to process for estimating and for determining what materials I need to purchase. So I'm going to go back over here, and I guess before I start in this example, basically what I'm going to do in this example is I'm going to make these rafters here on this end as an example of something called specification-based design. And specification-based design is something where instead of making the part manually, you go in and use VBA and you fill out a user form that has the material properties and the geometric requirements for a part. And once you put those in, the programming goes out and checks an existing database to make sure that part doesn't already exist. And if it does, it lets you know. It tells me what the part number is, so I'm not duplicating parts. And if it doesn't exist, it goes ahead and it makes it for me. And it holds all the parts consistent. They're drafted all the same, no matter how big your drafting department is. And then it also exports the data for that part, so you can find it in the future, and you don't have people searching for parts within a database. This was very useful in the last job I had. I was a designer for switchgear, and I did the sheet metal enclosures and the bus design. And the switchgear basically is an electrical distribution building. It's just a huge, the analogy would be it's just a great big fuse box like you have in your house. And in your house you've got individual breakers. Well, this is a full-size building, and it's got, the breaker boxes were basically 36 inches wide by 95 inches tall by 95 inches deep. And they had breakers in them. And so power would come into the building, and then from that building power would be distributed out. And these buildings were used in substations to serve different neighborhoods. They were used at manufacturing facilities. Power would come in, and then they would distribute power to different parts of the facility and that type of thing. So when I went to work there, they used Inventor. And they had over 30,000 parts. And the way they were doing it is they would try to figure out what their parts were just simply by filling out the descriptions and the comments. They didn't have any data on the actual width of the part, the thickness of the part, the material used, or anything else. And they were having issues with duplication of work. They were making the same parts over and over again because they couldn't find them in the database. And then they were also seeing that the work was actually slowing down because they were spending a majority of their time searching to see if a part already existed. So with this example right here, what I was able to do is capture their part envelope. They used walls, roof panels. For the sheet metal side, they had walls, roof panels, decking, angles, all kinds of different little parts, but I was able to capture just through one template all the different options that might be available. And then from that template, the user could specify a flange, a width, a height, the material thickness, and all that data would go into a database file, and then when somebody went to make another part, they could find it right away if it already existed. And so this is just a small example of that type of application. So I'm going to go ahead and get started on this. So basically, what I'm using, the API is basically right here. I'll go to the Visual Basic Editor. So this is the Visual Basic portion of AutoCAD. And what I have in here, these are all the macros. There's a bunch of them. And then there's some forms. And so within here, the timber design form is this one right here. And so when I run the program, it's going to use this form as its basis. I've got other programs in here, like this is a center of gravity. In the equipment that we used in the switchgear design, there was a lot of heavy equipment in there, and it was distributed all throughout the building. And they built the building, and then they had to pick it at the plant, put it on a truck to ship it, and then take it out to the site, and then pick it again. And so I would put in the equipment here and where it was located within the building, its weight, and its X, Y, and Z coordinates. And then from that, it would tell me what the center of gravity was for the entire assembly. And that way, we could give them recommended pick points. This one here is a bend compensation program. So within Inventor, things should be set up so it'll figure out your flat patterns without you having to do calculations. But this right here is just a bend compensation program, so I can tell it what the inside radius is, the bend angle, the thickness of the part, and the K factor, and it'll tell me, how much I need to subtract off from a folded part to get a flat pattern if I'm doing it in AutoCAD, which some of the work they did there was in AutoCAD. And so this just made it quick to verify what the flat pattern should be for the laser. So with that, I'll go ahead and get started here. I have an icon up here to run the program to make timber parts. I have an icon called Make Timber, and then it's got a shortcut name called MKT. So I can just type MKT in here at the command line. So I could hit the icon or just type that in. And what it's doing right now is it's looking at the existing database, and there's 8 parts in the existing database right now. So it loaded those, so it has it in its memory. So for example, I've got a header. Let's say I wanted to make a 2x4 header that was 33 inches. It tells me that, hey, it matches part HDR2. So it already knows that's in its database. Here I'm going to make the rafters out here on this end. And so I'm just going to go to rafter. And when I hit any of these different entities, it knows what the input needs to be to make that part. So wall sheathing, I can put in a cut or a hole. So these are all the different parts I can make with this program. I can make headers, hips, joists, plates, rafters, ridges, roof sheathing, studs, valleys, and wall sheathing. And in this example, I'll just make rafters. They're going to be 2x6. The first one is going to be this long rafter right down the center that frames into this ridge. And so it's going to be 155 and 3/16. It's got a roof pitch of 5, a tail of 22.5, and a seat cut of 4.5. And it doesn't have a bevel because it's not framing into the hip. It's a square cut on the end. And then I have a material. I could pick anything from Douglas fir, laminated veneer lumber, SPF, Southern Yellow Pine No. 2, or just treated lumber. And the descriptions and the comments in this, they're controlled. So I can click down here, but I can't edit these. These will always stay the same no matter what, which is similar to what Inventor uses. And in this case, I don't want the user being able to change those things, simply because it keeps the descriptions in the same order, keeps everything consistent. And when they're exported to Excel, for example, other macros could be written to go ahead and determine different things from these data sets. And the consistency here is important in order to make sure that that programming is going to be able to not lose anything as it goes through its cycles. Typically these things here with this system, the description and comments don't get used too much. The description might be something that shows up in a drawing sheet. It'll be something that will automatically fill in on a title block along with the comments for use out in the shop or through the fabrication department. So anyway, I'm going to add the part. And right now it tells me it's got a part count of 0. And so I hit add part, and what it did is it made a part rafter 1. It hasn't made it yet, but it's in its memory, and it assigned it a part name of rafter 1, and then the submit data box comes on. And it was off before because it didn't have any parts in its memory. But now that it does have one, when I hit submit data, it'll go ahead and make any of the parts it has. So I've got one rafter made. So what I want to do is I want to do these other 2 rafters on either side. One's got a right-hand bevel, one's got a left, and they're 129 and 5/8. And so everything basically is the same. I'm just going to do a left-hand bevel, and then I'm going to do a right-hand bevel. And then I'm going to do the next rafter, which is 103 and 5/8. Add that part to the right, its right-hand counterpart. Then I'm going to come back here, and the next one I think is 77.625. Do the left hand, do the right hand, and then do a 51.625. And then do a right. And so I made 9 rafters, which would be the center one, and then that'd be 2, 4, 6, 8. And then I guess there's one more. I think that would be 20. I'll just leave that alone. That'll be enough. So I did 9 parts, and let's say I went back, and in this session, let's say I tried to go back and make that other rafter again, the first one I made. Right now, since it has a bevel, it sees that I can add a part because it sees that it doesn't have one of those with a bevel. But if I do that, then it goes ahead and just tells me that part's already made. So now I'm going to hit submit data, and it'll just go through and make those parts. So it's thinking right now, and then it's going to pop up a progress bar. And it just tells me through the progress bar what part it's making and what its name is. And these are 3-dimensional parts. So to draw these by hand, it's not as easy as just copying and modifying the bevel. It can be a little bit cumbersome, so having this automation works pretty well. Then the last part of that, what it did is it just exported it to a Timber database. It's called timber.xlm. So I'm going to come in here and look at it. It's under the Timber parts. So what it did is it made rafter 1 through rafter 9. And then there's this Timber XLSM file, which is its reference database through Excel. And so in that database, it's got the name, part type, material, description, comments, and then it just has the different geometric parameters. And then over here it has an overall length. So the input length, for example, was 155 and 3/16 on that one rafter, but its actual length is 181.534 because it has a tail on it, and it's also got angled cuts at the end. And this right here is another macro that it figures within the AutoCAD program. It goes to another macro, and it determines what the overall length of the part is, and sends that out simply for material procurement or material utilization. If it thought the part was 155 and 3/16, when it went and ran a program, it would think that it would only need a 14-footer to make that part. Well, since it has the actual length, it knows it needs a 16-footer at least to make that rafter. And so that's that. So I guess while I'm here, I'll look. So I made the parts. And so while I'm in here, I'm going to give another example. So because I can do it kind of reverse too. There's a couple options here. So let's say for some reason I lose rafter 6 through rafter 8. Let's say for some reason those files get corrupted or they're lost or somebody deletes them by mistake and they're out of the database now. I can just come in here and I can type TFD, which means timber from database, which is this little tree up here. And I can hit that, and what it's going to do is it's going to open up that file. It's going to look at all the part names, and then it's going to go to the Timber database and make sure there's a DWG file for each of them. And any of those files that don't exist, it's going to update the database so that they're there. So what it did there was it just went through and it went ahead and made 6, 7, and 8 again. It just went ahead from the Timber database and made those. Another option is, let's go back here again. I guess I'm on this topic. So let's say I'm on an airplane, or I'm traveling, or I'm doing something where I don't have a computer that has AutoCAD on it, or I'm not in a place where I can really lay out very well to do AutoCAD. So I want to make a bunch of parts for a project, And I'm using specification-based design. So what I can do is I can come in here to Excel and basically have the same programs within Excel because they're both in VBA. So they transfer very well over to Excel to use the same user forms and everything. And I've got a program here called Make Timber in Excel. And so I want to go ahead and design this project. I've got some 8.5 by 11s or some smaller sheets, and I can do hand calculations. And then instead of needing to draw the parts by hand, I can come in here and I can say, hey, I want to make that rafter. It's going to be a 2 by 6. It's 155.1875. 4.5. And it tells me, hey, rafter 1 already exists. So then I think, well, I'm going to go. So I go through all the rafters except for the end ones. And so I find out I need to design the end ones, and they're 25.625. And I need to do a left. I add the part, it makes it rafter 10. I need to do a right. I add the part, it makes it rafter 11. I hit submit data, and basically all this does is just exports the data to the timber file, the timber database file. So when I get back to the office and I have access to a computer with AutoCAD on it, I can just come in here and I can do the timber from database again. It'll check through it, and those two parts, it should make rafter 10 and it should make rafter 11. So there's rafter 10 and there's rafter 11. And so they're done. I can be very productive even without being at my desk at a workstation. And so I made all the parts through specification-based design. And so let's go back to the main project. So let's say I made all the parts, and now I just want to export a bill of material for this. So I go in, I can type BOM, or up here I've got an icon, export bill of material. I hit enter, and it goes through and it looks at all the parts here, and it found 71 unique parts, and then it goes through and makes sure that they're all uppercase, and then it goes back and it compares the 71 parts it found to the timber database. And it goes through and just processes that data and exports it into a new bill of material file. And so this is going through right now. It's making the bill of material file. And it's done. Okay, so now it finished making the bill of material, so I'm going to go over here to Excel and I'm going to process that bill of material to get costing and material utilization. So I'm going to hit process bill of material. And what it's going to do is it goes and looks in this folder right here there's a bill of material folder, and so it just looks at any of the bill of materials in that folder. And there's two of them in there right now, and the 3D Garage Blocks XLSM is the one that it exported. So once I select the file, the submit button comes on because it's ready. It can go ahead and process it. I want to give it a 10% overage for material waste, and then let's say the purchasing, where I'm purchasing the material, they have a 7% sales tax. So I hit submit and it goes through and processes and tells me basically what it's doing. It's checking, it's separating the material, so there's 2x6s, 2x8s, 2x12 Southern Yellow Pine, the LVL. And so it makes a material list, and then it makes a costing sheet, and then it combines them all at the end of the program. And so now that it's done, I've got a costing sheet that this is the exact material I need without any waste, and this is what it would cost me. The subtotal is this, with $1641.75. It figures 7% tax, and then that's the total cost. And when it processes the bill of material, I've got a pricing sheet from my supplier that I know what their up-to-date costs are, so I can get good estimates on my materials. And then over here, I've got the material estimate with a 10% waste, which if I'm bidding the project, this is the number I'm going to base my bid on. And a lot of times when I was working on my own and I did bids, I would bid it where the bid would be labor and materials not to exceed. The labor would be fixed, and then the materials wouldn't exceed this amount, like this $2156.57. But then when I billed the owner at the end, I would bill them for actual material costs rather than, I wouldn't pocket anything that I didn't use. So let's say I did a really good job and had no waste whatsoever. Their estimate would be $2156.57 for materials, but when their final bill came in, it would be about $400 cheaper, or $300 or $200. So I would give that back to the customer, and that was always a pretty good selling point first off, everybody knew exactly what it was going to cost going into the project, and then they knew at the end it would probably cost them less than what my bid was, just simply because of the material utilization. Then there's a cut sheet, and what this is it just, there's 4 2x4s by 192 that the fabricator out in the field or wherever he's at, he's going to know that there's 4 16-foot 2x4s that he needs to make this PL20 out of. And then he goes and gets 2 16-footers, and he makes the PL19 and the PL2. And then there's 14-footers and 12-footers. And what that does is it tells people exactly how to use the purchased materials so that they're not cutting like a PL11 out of a 16-footer. So it's, and then you end up having more waste. Or you end up cutting a smaller part from a longer piece of material, and then that longer piece of material is gone and you needed it for a bigger part. So right here, this just helps people in the field that they don't have to determine on the fly what parts they should cut from what materials they've been provided. This actually tells them specifically how to cut each part. And so from here, that's for the fabrication side. The cost sheet would be for estimating and for ordering. So these are the framing members that would need to be ordered from the supplier in order to build that garage. So with that, I think that's it. Hopefully I didn't miss anything. It's just a quick example. It's the drafting software. A lot of people get caught up in the graphics and the computer side, and I work more towards the project side. I use the programming and the drafting software as a tool to generate what's making money. It's kind of like using a skill saw on a job site. You're going to cut the lumber and make a house. I think a lot of people use drafting software. They're so keyed in on being able to use the drafting software. That's their expertise, and they don't think outside of that to what they're actually trying to do. And so, to me, using a skill saw should be secondhand to somebody that's building a house, and I think the drafting software for a designer should be secondhand to their actual job responsibilities and to their value. Anyway, with that, hopefully that sheds some light on what some of the capabilities are. Thanks.